Okay, so welcome to the next of the midterm reviews for the Regent's physics class. So we're taking a look at a few of the problems, part 2 problems. Now some of these you need a protractor and ruler. I'll do my best to sketch these on the screen as I see fit. But yeah, so come to see either of us, Mr. Prusnowski, myself, if you have any questions on this. Okay, so the first one, we have a speed versus time graph, and we have some sample data going on here. So I'm going to take a moment and just graph this data. So you can see here that we have some data. It's displaying a linear trend, so when we want to actually go through and draw the best fit line, you're going to want to do this with a straight edge, but for the purposes of the video, I'm just going to do it with freehand here. And so we would get a best fit that would look something like that. Okay, now here's the important thing, is you need to find two spots that cross the grid of the graph paper. So if I was going through and doing this, I would see that, you know, I have a spot right here that crosses the grid of the graph paper and a spot right here that crosses the grid of the graph paper. Okay, so you're not using 2 points. Okay, so don't take like that point and then just do rise or run. Experimentally, you know, I'd ask you, then why'd you take, you know, 6 data points if you're only going to use 2 of them for your best fit? Okay, so when I went through and did this, I found crossings at, so I'm looking at A, it says plot the points and draw a best fit. Okay, so done. And then for B, it says calculate the slope of the line. So that's a change in y over a change in x, rise over run, and so I got a value of 5.5, okay, minus 0, and then over that was 5 seconds minus 0 seconds. Another experimentally, you know, something that you would consider is you want to try to use as big of a spread as you can. Okay, so the fact that we have the best fit coming all the way here to all the way there is a good thing. And then if you do this, you would get a value of 1.1, and the units are meter per second or meter per second squared. Okay, so then so calculate the slope of the line. I got a value of 1.1 meter per second squared. I would say tolerance-wise, if you're getting something between 1 and 1.3 meters per second squared, that would mean that you are, you know, on track there. What's the physical significance of the slope? Okay, always use the units to help you out in order to answer this. So we have a meter per second over second, okay, which of course is a meter per second squared, which is a unit of acceleration. So the slope represents the acceleration of the graph. Calculate the area under the line from a time of 1 second to 4 seconds. So we would essentially find an area that would look like so. I got to scroll up a little bit here. And you will notice that you get 2 shapes. You can create and turn this into a rectangle, and then you can turn it into a triangle. So you find the areas of each of those independently and then add them up. Okay. For the rectangle, I got, so the area of the rectangle, which of course is length times width, I got a value of 3.6 meters. And then for the area of the triangle, which is of course half the base times the height, I got a value of 5.6 meters. And so for the total area, I got a value of 9.2 meters. Okay, so that is our answer for the area. And then of course the question is, what's the physical significance? Well, once again, use the units. It's got a unit of meters. So since this is a actually, this is a speed versus time graph, so the scalar, so the physical significance is a distance. If this were a velocity versus time, then the area would represent the vector displacement. Okay, so if this is velocity versus time, then the area represents the displacement. And the only thing, remember, is the difference between these two is that one's a vector, displacement being a vector, so it's your change in position, and then your distance is the scalar, and that's just simply how far you have traveled. Okay, so the next problem, and